Valley. He is going to tell you about the V-Motion project. Now, Jeff was one of the two developers who did this amazing trailer. Seeing it personally, I must say, I thought that it was staged, and I didn't actually cross my mind that it could actually be real, that they were using this technology. Absolutely outstanding. So I'm going to hand it over to you, Jeff.
Cool, can you guys hear me? Yeah. Right, so yeah, I'm Jeff. I'm lead developer at a company called Assembly. I'll just play our show reel, tell you a bit about us. We're a small, I guess 10 of us, just down the road near Victoria Park Market. We do mostly TV ads like this, highly visual, 3D motion graphics, pretty technical. We also do digital stuff, which is my side of things. So we like to say we're sort of that crossover between art and science. Really clever people who have kind of technical but also artistic kind of leanings. In my background, I'm a programmer, went to school for programming, got into web development, eventually got into doing big fancy websites like this, but also have a background in gaming. Did some, these are just some Flash games, but game development, I reckon, is probably the most interesting programming you can get into. If you're at all interested, it's really challenging because not only do you have to worry about the technology and the programming and the art, but you also have to worry about storytelling and emotional engagement and bringing someone along on a journey with you. And I'm also really interested in interactive art, and these are some images of music videos and some other projects that I'll talk about in a little while. But first I want to introduce the Kinect, because the Kinect is the technology behind the V-Motion project. And it's something I've played around with a little while before the V-Motion project, so I'll tell you a little bit about some of those projects as well. So the Kinect is an infrared motion sensor, and you can see there's the three little circles, and one of those is an RGB camera, like a regular web camera. One of those is an infrared projector, and the other one's an infrared camera. And the way it works is the projector projects out this array of dots that we can't even see with our naked eye, but with an infrared camera you can see. So the infrared camera sees the dots, and it's a very particular pattern of dots. So the Kinect reads where the dots are, it knows where they should be, and by the way that they're distorted, it can see how the shape of space is warped in front of it. So it can sort of reconstruct depth alongside of image. So here you can see a sort of a visual representation of that. The Kinect doesn't see color, but here I'm showing things that are closer to the camera as red and yellow, and then it kind of fades to green and then blue and purple. A good way to think about it is sort of like one of these pin toys. So you're not getting a full 3D picture of space, you're just getting sort of a mesh pushed forward. So you can't see around and behind things, but you can see the form of things. And the first project I worked on with the Kinect was a music video for a band called Pajama Club, which is Neil Finn and Sharon Finn and SJD. And this was a collaboration with Sam Peacock, who's a really amazing music video director who usually has pretty insane ideas. And his idea for this one was a music video that was recorded with the Kinect, so using the Kinect as a camera to record, and then played back on the web without any plugins, which is, if you know anything about developing for the web, it's pretty insane. But the first thing we had to do was figure out how to record with the Kinect, because the Kinect is meant to sit on top of your Xbox and watch you play. So this was my Kinect recorder version 1. It's just hooked up to a battery pack and a little inverter and my laptop. Now I took that and wrote a little program that would see what the Kinect saw and then save it to a file, and then was able to play it back. So this is a early test. So you can really see that pin cushion kind of the pin toy thing because of the way you display it usually has a point cloud. But what's really interesting is you can spin around and see it from different angles. So this is just a web tech demo. But you can see the power of it. It's pretty amazing to have that control to just spin around and see things from all angles and to stop time. And I'll just skip ahead a little bit to the finished video. So again, this is a website. It uses WebGL, so it's not Flash or anything. You just go to it and it works, and you can interact and move around. And there's those cut scenes that we recorded walking through the woods, and then there's these band playing scenes where you can actually see Neil and everyone playing, and kind of you have a bit of control to spin around. So we had to do a shoot for all of that, a studio shoot. So this is the camera version 12, I don't know, but you can see it's got a little HD monitor, so the director could actually see what he was recording, and it was on a regular camera rig, so everyone could work like they would normally with a camera on a studio shoot. And the way we recorded the body, because the resolution of the Kinect was pretty crappy, if you wanted to get a full person, you would lose a lot of fidelity, so we recorded each body part one at a time. So for each artist, we recorded each song 5 times. So arm, chest, head, legs, for each of the 3 band members. And we did 2 songs. So it was a long day. And we also got to go behind the scenes of the Auckland Museum. And they gave us access to these big crazy lockers full of stuffed birds and other crazy artifacts that we sort of 3D scanned with the Kinect just by taking still images from 4 different sides and then kind of recompositing them together. So sort of taking 4 of those pin toys and putting them around each other, you get a full 3D image. And we used those for this, which is the sort of the B side. So the other side that you saw, that was the main track, but we also did this secondary track, which was just sort of showing off the tools that we developed to create the other one. But this is, so as a user, you can just come and just play around and manipulate these 3D things playing in real time. It's quite weird. Yeah, and there's some of the objects that we scanned. So you like ginormous penguins? You should check it out. And then just quickly, another project I did with the Kinect was Growth, which is an interactive artwork that I did for Digital Art Live. And this was using the Kinect in a more traditional way. So it's just a motion sensor, so we can see what's happening in space before it. So it's just seeing what kind of motion is happening. So it creates this really nice effect where if you just walk past the work, a little sea of grass grows in a path, and then if you move more and more, sort of little shrubs grow, and then trees, and then when you stop moving, they slowly just die away, back to nothing. But it's quite nice because it's got depth, so if you're far away, then the trees that you're growing are quite back in the horizon and quite small, and if you're up close, they're big and full screen, quite simple. So all of that kind of work is what led up to the V-Motion project. So so Assembly, the company I work for, our clients are mostly advertising agencies. So advertising agencies work for big companies like Frucor, who's a company that owns V. And they came to us with this brief. Colenso BBDO is their agency. And they had this idea, because V has a history of kind of doing these big, kind of elaborate stunts with technology, and they had seen what had been happening with the Kinect, and they had this idea of, well, what if we made a machine that actually made music and was really cool and was a collaboration of lots of different interesting people. And so they put together this team. So there was us, Assembly, Fugitive, which is another team of developers, James Hayday and Joe Little, who are music producers, Josh Cezanne, who's a hip-hop dancer, and Thick as Thieves are a film production company who documented this whole process. The idea was to kind of get this warehouse space, get all these people together, and then document the process of trying to create a machine that made music through motion. So they kitted it out with all sorts of V paraphernalia and some computers and a bunch of time. Well, not really that much time. We had 2 months. But when I came on board, Paul Sanderson, he's the other developer. He had been working for a little while. And this is what he had come up with at that point. So this is using the Kinect in a more traditional way. This is what the Kinect is sort of meant to do. it sees that depth image and it does some really complex math to pick out the shape of a human and then map a skeleton onto that shape. And then as a programmer, you can say, tell me where the hands are, tell me where the feet are, how many people are in this scene. And most of the games that you play with the Kinect use that kind of technology. And that's really clever. And so what Paul was doing was saying, we'll map different motions to what is essentially different knobs. So if you notice, as he rotates the hands, the value is going up and down. So that's the equivalent of turning a knob. And why that's important is this is Ableton Live. This is what people who make music, especially if you're performing live, use to kind of break a song into different parts. And normally you would trigger the changes and the different filters with an MPC, which is a piece of hardware with lots of knobs and faders. And Ableton's brilliant in that you say, I want this physical knob to turn this little knob in the software, or this affect this filter, or start this noise, stop the noise. And so the basis of the system was Ableton with that system of the hands control this filter, the height of how high your head is off the ground controls the volume. So if you duck, it gets quieter. Just coming up with a way of mapping how you move to things in Ableton, which is really clever and really powerful. But the musicians who are working on the project, they wanted to be able to play in real time. They wanted to be able to play like a keyboard or a drum. And the problem with that system was, in order for the Kinect to pick out your silhouette and to map you, to draw that skeleton, it has to do quite a bit of math. And I think it has to even wait a few frames to see how you move in the future, to figure out where you are in the past and all these things. But so that introduces lag, which if you're trying to play music and there's a lag, so you hit the drum and then you hear the noise 30 milliseconds later, or it just doesn't work. And trying to play along with music in real time, it doesn't work. And we just couldn't figure out how to get around that lag issue. And because of that experience with the music video and the interactive artwork, where I hadn't been using that skeleton stuff, I'd just been using raw depth data. I hadn't really experienced any of that lag. So I thought, well, maybe if we just use raw depth data, there's something we could do so we can actually play real time. And this is one of my first tests. So it's quite simple, but the way it's working is you just kind of set an imaginary veil with the Kinect and then say anything that crosses this line triggers a note. So if you stand there, you just kind of, one hand is hot, one has a snare, one has a kick drum, and it works and it's brilliant. But it was pretty limited. So this was kind of version 2 where So it's a bit more powerful. You can put some more notes in there. It's more musical, but it's quite hard to play. It's hard to know when you're hitting a note if it's just air. You know, when you play drums, you have the resistance of the skin of the drum or the keyboard. You know when you've hit it and you know when to release it. But when you're just moving your hands through air, you're never quite sure if you're in or out, and hitting precise notes is quite hard. So that became the next challenge, which we solved. And we did this. So as you can hear, he's playing a really complex drum beat in real time. And the way we did it is actually really simple, because you can see how we have that silhouette of the figure. And with the Kinect, because it can see depth, you just tell the Kinect, ignore anything that's beyond 4 meters. So if the person's standing 3 meters, then you just get this blackness behind them, and then you have the shape of the person. And then we just said, anything in these boxes outside of their arm's length, anytime there's pixels of body in that box, that's a note. So it was really simple and really fast. And because they were to the sides when you moved your hand out to the side, you kind of had this natural inbuilt resistance. Like your arm only goes so far, so you know when you've hit it. So it just became suddenly really kind of intuitive to play. And yeah, really powerful, because now we could play drum beats, we could play keyboards. So we had the system, we had that system that Paul had developed, which was really powerful, all those filters and faders and being able to map it to all sorts of different motions. And then the speed of the real-time sort of keyboard drum thing that I had developed. So we needed to make the choice of, do we want it to control or do we want the speed? So we chose to do both. And we did both by having 2 Kinects and 2 computers and 2 completely different systems. So one computer was running the sort of skeleton tracking, and one was doing the depth data keyboard stuff. And it also was a good way of splitting the work in half. So Paul was able to focus on the audio side, and I was able to focus on the video side. And then just our systems talked to each other and shared all the information. But if anyone who's worked on the Kinect, when you have 2 Kinects pointed at the same thing, like as I was explaining before, they shoot the dots out and they read the dots. So if you have 2 of them pointed at the same person, one's going to see the other one's dots, and they're going to get confused, and it's going to be a mess. So we had to figure out how to fix that. And we fixed that by rubber band attaching a little motor from a mechanical car, because it turns out if you vibrate one of the Kinects and keep the other one still, the one that's vibrating sees the other Kinect's dots as blurs and just ignores them. And the other one that's still sees the moving ones as blurs and ignores them. So you just put this little motor on, it vibrates, and both Kinects are perfect. So if you watch in the actual video, you'll see that little thing attached and just vibrating away. So at that point, this was our system. We had the 2 Kinects. We had a little monitor on the ground there. This is James. He's one of the musicians who broke the track down and put it into Ableton. And he's doing a run through. But you can see it's quite ugly. There's the visuals projected on the wall, but they're pretty basic. They're just programmer art. And there's a little area marked out on the ground that kind of shows him where he needs to move. But it wasn't very sexy yet. So the first thing to do was to find a dancer who could move and make it interesting. So Josh, there was an interview process, and they discovered Josh, who turned out to be amazing. He's a great young dancer, really talented, but he also was really enthusiastic about how he thought the machine should move to his motion. So he had ideas of how he wanted to control each instrument, and so we then shaped the machine around him and how he wanted to move, which was really great. And then it's still pretty ugly. You can see the projection on the back wall. So then the job became to make it into a big spectacle, to make it into a show. And this was some early concept art that Matt at Assembly put together. You can see most of the elements are there. We knew we wanted to do a big projection, and we wanted to have the artist in front of the projection, silhouetted, looking at the wall. So he wasn't performing to us, the crowd. He was engaged with the machine. He was looking at his display. And so the creating of this display became really important because it was the main tool to communicate to the audience how the machine worked and how each instrument was being controlled by what he was doing. So these are some early concepts for the design of the elements of the machine. So we got into the green fine lines pretty quickly. We took a lot of cues and inspiration from audio software and waveforms, and pretty soon got onto this kind of circular look, which worked great because it kind of fits around the human body quite well. And then started playing around with putting the instruments around him that he could kind of access in some way. And it quickly became this. And it was really important to us that every element on the interface was doing something, was real. So the purple ring on the outside, that's sort of that's the sound wave of the track as it's being written. So there's a little head there that's kind of writing kind of the tapestry of the song as it goes. There's some different, you you can kind of see the yellow bar and the little red bar on the outside. They kind of go up and down, showing different readings depending on what instrument he's doing. And there's a little reel-to-reel in the lower left. You'll see as he creates a loop. So sort of those salmon color little markings on those inner rings, those are notes that actually write as he plays the keys. So if you're playing music in a MIDI software, you'd see kind of bars of music being written and you can edit them. So those are kind of written in real time as he plays, and then they're rewound and sucked into a little reel-to-reel and then create a loop and then stack on top. It's all this little stuff, but it was just really important to us that it was all real, so people watching it could understand how the machine was actually working. And now I'm going to show you some of our, this was pretty far down the process, but this is Paul, the other developer, playing through the different instruments, because what we did was we broke the track into different sections, and each section the artist was controlling a different aspect of the song. He's a programmer, so he's not very good. This one has this kind of senses how low his body is to the ground, and it gets quieter and quieter as he gets lower and lower. And then you'll see in the actual video, there's another one where once he's really low, he starts to stretch the sound out and pull it out, and it kind of opens the sound out and reduces the filters. And we also created these sprites, so when he hits a key, kind of shooting out of his hand are different. They're called sprites, but they're just little animations that kind of visually represent the sound. So I'll show you the final video and how all these elements came together. So what we ended up doing was a big shoot down, just down the road actually, on Dorr Street. We hired out the whole car park and got these giant projectors projected on the entire facade of one building and the top of another. And yeah, so we did it like a music video shoot. So we did 6 takes, I think, on the day. And Paul and I were programming up to the minute we started. It was pretty fantastic because no one had seen it yet. The client was really trusting in us, and usually on something like this, they want to see like every step of the way that it's going to work. But because of the way it was structured, where there's these web episodes and all these personalities, if it didn't work, it was still a good story. So it was just, if it worked, it was great. And along the way, most of us pretty much assumed, because we're from the TV commercial post-production world, we're used to, we'll try it, if it doesn't work, we'll just fake it. That's what we're good at. So the fact that it actually worked pretty much surprised everyone, I think. But, so for this final show, it was pretty fantastic to just hit the play button, it turns on, and then Josh went out there and just nailed it the first run through. And after releasing websites and just hitting deploy and then going to watch his performance, and the crowd erupts and cheers, it was pretty amazing. Hard to go back to websites. And so I'll just show the final video. Thank you. I don't know if we have time for questions.